Hey folks, welcome to another episode of the Data Eng Meetup. We've got a special edition for you today where we've got John Jackson all the way from Seattle taking us through what's new with MWAA and a recap of the Airflow Summit. The big announcement out of Data Eng Bytes, though, recently is that we've just announced our conference dates on the 27th and 29th of September. We've got the State Library Victoria as a venue for our Melbourne event, which is on the Tuesday. That's going to be fantastic in the Conversation Quarter and the Village Roadshow Theaterette. It's going to be such a real treat to be hosted at those two venues. And then in Sydney, we're still confirming our venue, but stay tuned for that one because it's going to be amazing. So we've got tickets on sale now, and our call for papers is open for another month, I think. So really excited about what you all sort of put forward. We've already had a really strong response to the CFP so far. Diversity is a big aim for us this year. We want to increase our diversity in amongst our speakers, our attendance as well. So stay tuned for more announcements on that front. But without further ado, I'm going to welcome John Jackson to the live stream. Welcome.
Thank you very much for having me, Peter.
You're absolutely most welcome. We're super excited. I know there's a huge amount of Airflow users in the audience, and I'm sure there's more than one using MWAA already. And it's really within my wheelhouse or my passions, the intersection of serverless and data engineering. So very much looking forward to finding out more about MWAA and some of the new features that you're rolling out. So I might just let you take it away.
Absolutely. Thank you very much. So, and thank you for inviting me. Great to be able to chat with the crowd here from in the Australia area and wherever else you happen to be tuning in from. Just some background on me. So I'm, as Peter said, I'm John Jackson. I'm the principal product manager responsible for Amazon Managed Workflows for Apache Airflow, or MWA. I was also very privileged to be part of the Airflow Summit committee. The Airflow Summit just wrapped up a couple weeks ago, and I did a few presentations, and we had some fantastic content on there. Far too much content for me to be able to summarize myself. There's so much wonderful expertise across the Airflow community, and so really, just as a preface for this, really encourage folks to, if they haven't already, go to airflowsummit.org, check out all the cool live streams that are on there. It will also be on YouTube soon, but it's all available to stream today as well. You can go check out all the sessions, and there's some fantastic ones in there. So, since I'm not going to be able to cover everyone's sessions, I'm going to do a sort of a recap or a refresher on the sessions that I was responsible for, and hopefully open that up to some questions for folks here as well that maybe didn't get a chance to either I didn't get a chance to ask them, or didn't have a chance to see some more about it. So we're going to start out just, I'm going to give a recap of what is Managed Workflows for Apache Airflow. I'm sure not everyone has had a chance to check it out yet. And go over some of the architecture and really sort of delve into a couple of the key points. I did cover all this again on the Airflow Summit, but I want to sort of recap it and give folks here a chance to visit if you get a chance to. And I'm going to cover a couple of key topics around how to actually deploy this stuff as well, around the best practices and how to scale it, and sort of some of the stuff that's coming up. And I'll do my best to get everything done in a relatively short order so we can have a good chunk of time for questions. Because there are just the nature of sort of this streaming video, please, if you have questions as you go along, go ahead and add them in as we go, and then we'll just sort of address the questions at the end. That way, if there's a bit of a delay, we'll hopefully get to everyone's questions. So with that, let me just sort of start with what is Amazon Managed Workflows for Apache Airflow. So we're running the same open source Apache Airflow without any forks or changes or customizations. That, of course, begs the question, what's Apache Airflow? If you're not familiar, Airflow is an orchestration platform. It's very popular with data engineers and data scientists because essentially you can describe your entire workflow in Python the exact same way you would write the rest of your sort of code as for any other aspects of your data pipeline. So what we've added to Airflow is we've made securing it a little bit easier because we've integrated directly to AWS's IAM, which is our identity management. Same way you log into consoles and things like that today. It's integrated directly with AWS services. So I know, Peter being very much a serverless guy, it's all running on ACS Fargate. So there's no sort of fixed EC2 instances whatsoever. All of the logging and metrics are done through CloudWatch. We use S3 to store all your assets like dags, your workflows, and things like that. And we've made it relatively easy to deploy. You can set a stand up right from the AWS console. You can do it through CloudFormation, API CLI, that sort of thing. So just some background on the service. We launched this back in November 2020. Since then, we've had a couple Airflow versions, and we've expanded to a few more regions. We're going to continually add new Airflow versions, new regions as we go along. But that's sort of where we are today with the product. So really wanted to sort of touch on, I sort of mentioned Fargate and CloudWatch and how do all these things fit together on this. So what we've done is, in order to be able to make this integration platform that is Airflow work within your environment, we're launching the actual Airflow schedulers and workers, which are the Airflow scheduler, not surprisingly, is the bit that schedules workloads. And the worker is the stuff that that actually does the work. So we actually run that in your virtual private cloud or your VPC. We run those ECS Fargate containers there. That way, as long as your VPC has access to these things, then you'll be able to orchestrate workloads in that. So if you have on-prem or anything else that you need to access, if you have Redshift clusters that or Postgres databases or whatever you've configured, as long as you can access it from your virtual private cloud, MWA can handle it for you. As I mentioned, we use CloudWatch for the logging and metrics. So Airflow has, not surprisingly, logs and metrics that sort of show you the behavior of the system. And so that's all done through CloudWatch. We host the dags. So Airflow describes these workflows as directed acyclic graphs, or dags. I'll show you some examples in a second. And those are all hosted on S3 along with plugins and Python requirements that you might need. Airflow uses a Celery as its queuing broker, and we use SQS as the queuing mechanism behind that. The open source Airflow images that we build upon are hosted in ECR. And then you are able to use your own customer managed key if you wish through the KMS. So that's sort of where all the workloads run for Airflow, right? And so the other aspects of Airflow is there's a metadatabase that stores all the state and a web server that provides a user interface. And so we host those within a single tenant service VPC, or another virtual cloud, or a virtual private cloud. So these are all 100% single tenant. They don't share resources between anything else. They are accessible from optionally from a public network or a private network. And I'll show you what that looks like in a second. And then, as I mentioned, there's also the single tenant metadatabase, and that stores all the state and things like that, and information that you may need as well. Given that, so this is sort of important in that this is the architecture that we have for Airflow, and really want to sort of make sure that we have this sort of laid out for you as well. And so let's go through and talk about a couple of key aspects of this. So I mentioned the Airflow web server is the UI. And so that user interface really has, we provide two different mechanisms by which you can access it. So there are a number of customers, such as financial customers, that require complete isolation of their data, no internet access whatsoever. And so for that, we have a private network option for the web server. And that basically exposes the web server through a virtual private cloud endpoint, or VPCE. It's that way it's only accessible for anyone that's inside your VPC. So that means via VPN or a Bastion or some other load balancer. That's pretty tricky to set up in some cases unless you're already sort of configured that way as sort of a corporation. So we also provide a public network option, makes it accessible like any other console page. So as long as you go into IAM, let someone configure their IAM principal to allow access to it. Again, IAM's the authentication management used for any AWS console page. That's all you need, and then you can just go through, click, it's a URL, and it's completely accessible just like any other console page would be. So to get into sort of the details of where the differences are there, and the reason why I'm sort of highlighting this is because sometimes this is a little bit of the trickier part in getting things set up. Your public web server option, as I said, it's pretty straightforward. From the internet, you go to a URL that's on the console page, you have access to the UI through the web servers, and then the web servers also have access if they need to load any Python libraries and things like that. However, for the private web server option, it's only accessible from the virtual private cloud that you've provided from your side. And then we've provided dedicated private link endpoints in for all those same services that MWA needs in order to function. But the key aspect here is the web server doesn't have access outside of the to load any additional sort of libraries from PyPy or anything like that. So one of the tricky bits in getting some of this stuff configured can be figuring out how all these libraries and things like that work. So for that, we provided an open source. Basically, it's the exact same open source Airflow, except we've just pre-populated with all the configuration options we do, and just lets you run it locally as a Docker container. So it supports all the same MWA versions that we have available to us with the same sort of starting libraries, and then a bunch of utilities that help you sort of manage your cluster. So, for a lot of folks, you can just sort of stand up an Airflow environment right away without any configuration. But a lot of times, if you have things, they're not built in, let's say DBT or Great Expectations or things like that, you need to add those providers in. And so Airflow has this mechanism by which you, all the different connection types are packaged as providers packages. And then the PyPy install is the way those are managed. So let's take a look at an example of that here. So let's say, Airflow 2.2.2, which is what we currently host on as the latest version we host on MWA. There's a newer version out available, but it's not available yet on MWA. The latest version that it provides of the Amazon providers is 2.4, so that's what we have built in. But let's say there's some really cool new stuff, like there's a Redshift data provider that's part of the newer Amazon packages. There's some new EKS providers, all sorts of cool stuff. So let's say you want to provide that. So at the top here we have our sort of what our requirements file would look like. Right, so first and foremost, you should always use constraints. Airflow is built on Python. If you replace a Python library with something that's not compatible, it's going to end up not working very well. So we want to make sure we use that as constraints always. And then we can just say, well, I want this new version of Airflow providers. So what I'm going to use is my local runner, and I'm going to run the test environments utility. And the output I get from that is that it can't install that. There's package versions that have conflicting dependencies. So we're just running the same pip3 install that MWA does at the startup. So we just know it's a pip conflict. For anyone who's not familiar with Python, pip is just the sort of the package management system that's built into Python. So when I go in and dig into the open source Airflow constraints that are built around what the Airflow version and library is, I notice that it actually explicitly calls out the 2.4 version of the Amazon provider, and Watchtower 1.0.6, which is the link between CloudWatch and Airflow. But we want to have that newer version. So what I'm going to do is I'm going to download this sort of constraints from Airflow. I'm going to replace the older line items with the ones I want. And then I'm just going to place that in my local runner plugins folder, and that way it'll be accessible from that container. When I go ahead and run that now, and I just specify now that my constraint file is in my plugins folder, I'm going to go through and provide the newer version, the explicit version I want from the Airflow or the Amazon providers, run it again, and we can see now it's successful. So this is great. We've tested locally. Let's say though, for example, I might have the private network option. I don't have accessible to PyPy. So one thing we provide as well is we have the ability to package these requirements, and it'll go ahead and download. It'll run a pip3 download on all of the library files and dump them in that same plugins folder. And then I can just zip up those plugins and specify that new customized requirements file that points to the constraints file in the plugins folder, and then I can get that latest version. So this is the Airflow UI. We can get that latest version in there. So these are library management is always going to be a bit of a challenge, and so this is a way we can do that reasonably straightforward. I want to provide one other example because I know it's really popular right now, especially with the data engineering community, and that's DBT. So similarly, DBT has some conflicts with the built-in constraints with Airflow. So I just listed them here. The Airflow specifies as a JSON schema and a packaging library that's different. So again, I just went through and took a download version of the Airflow constraints because I don't want to not use constraints. Not using constraints opens up the possibility of installing a bunch of incompatible things that will completely break Airflow. So instead, I'm just going to change a couple of things we need to. And then the other thing I found with DBT is don't try and install like DBT all. Install just, if I just need Postgres and Redshift like I did here, just specify those two. And then you can see also that then happily installs for us as well. And so that way we've got those DBT libraries. Now, one thing about DBT, if you're not familiar with this, is that everything basically runs as a bash command line. So within Airflow, you've got these bash operators that you can run. And so you can see here, I'm just running the bash command for DBT, and I'm running against sort of a test project I made. But one thing that a lot of the DBT projects need is write access, and Airflow MWA runs on ECS Fargate containers that don't have write access. They're restricted. So what I've done is in my little bash command here, I'm first copying I put all my DBT files into my S3 bucket, which gets synchronized to the MWA folder. I then went ahead and copied them to the temp folder. So that way they're on a write accessible folder within the Fargate container. And then as the next step, I'm going to run dbt run. Here's the project. And then the last thing I'm going to do is I want to be able to see the logs in Airflow. So I just ran a command cat the output log. And that way, when I go to the Airflow user interface, I can see the DBT logs. So those are really quick. And hopefully if you have any questions, I'm going to go through some of these fairly quickly to try and get through them and try and leave some time for questions. I do want to comment on a couple of best practices around Airflow and some things to look out for. So one is, as I mentioned, Airflow, all of our logging is done through CloudWatch and Watchtower. It's not the same as writing to a local file system. We did upgrade the Watchtower version to improve performance, but you can still run into throttling. So make sure you're aware of your own accounts, quotas, and throttling around things like put log event. The other part to the thing to watch out is make sure you have network access to all those things in the architecture we're looking at, and also make sure your execution role has all that same access, and be aware of there's a subtle difference when you're using Amazon managed keys versus a customer managed key. For those of you who are already familiar with Airflow, maybe you're running an older version or even a current version self-managed. It's a little different running it on a managed system where you're distributing across multiple different Fargate workers as opposed to running it on all in one. One example you've noticed in that DBT command, I ran everything in one bash operator. I didn't run it as a bunch of consecutive ones. That's because with multiple workers, you can't necessarily guarantee that one bash operator is going to run on the same one as the next bash operator. So that's why I had all the slashes and semicolons and running all the commands that depended on each other, like copying to the temp folder, running things and copying them back. Want to make sure those were all in one spot. And then last but certainly not least is sizing your system. These are not, you're not running on some one giant Fargate container, or one giant EC2 or one giant VMware or anything like that. You're running it on small workers, and you need to be able to say, okay, well, we're going to have limited resources on a per worker basis or a per scheduler basis. So understanding sort of how the different aspects of Airflow affect your ability to scale is super important here. So with that, let's talk about running these things at scale. So sort of dovetailing from one presentation I did at the summit into the next one. We're talking about Apache Airflow at scale. This is about you're running a lot of concurrent tasks. You have tasks that run for hours or maybe days. You have a lot of different workflows, these directed acyclic graphs or DAGs. And you can also have very complicated workflows, very complicated dependencies between one set of tasks and the next. So what sort of things affect your ability to scale Airflow? Well, one is that, Airflow is constantly parsing these DAGs. So the way it works is it actually goes through and imports the entire Python file that describes the DAGs all the time in order to figure out what's there, what's not. Is it something I need to schedule? Is it not? And that runs a fairly heavy load. And you can, as I said, Airflow is just written in Python. You can make it as complicated as you wish, and you'll see some examples in a second. So just understand that this load's constantly running. You also know that the scheduler is going to go through that scheduler component. It's going to go through and find all the interdependencies and try and figure out what to run next. The more complicated those things are, the harder it's going to work. And then the other aspect of this is that, while you can scale out the number of workers and you can have multiple schedulers for high availability, it's not as dynamic. Typically, these things are running in a fixed amount of compute. And so you need to sort of understand, how many workers, how many schedulers, what size these things are, in order to make sure you don't overload any one object. So I'm not going to dig into these next two parts too much, but just understand all the things that are going on the scheduler. It's running these task processors. It also has to run all these file managers, and for every file, it's got to load up a processor that does that. It's also got an executor that's responsible for taking things from the scheduler and moving them to the workers. So it's super complicated. And there are some things you can do to keep things moving along. So you can reduce the amount of time it spends parsing DAGs, tell it to wait longer between parsing them. You can also configure how long these things take to actually parse, how long it takes to take a look at a Python file and make sense out of it. Again, not going to go into a lot of details, but there's some fantastic resources on the Airflow documentation, really talking about some of these configuration options and how to handle the scale. There's another important way that Airflow scales workloads, and that is that even though it's written in Python, it's not meant to run the load. You're not going to rewrite a MapReduce directly into Airflow. It's meant as an orchestration platform, which means that you should be offloading work wherever possible. It should not be, the Python code in Airflow is designed to understand complicated dependencies between tasks. It's not meant to run complicated tasks. Those tasks should be run somewhere else that is more meant for it, right? Running it in a dedicated Kubernetes container, running if you're running Spark jobs, you wouldn't run those on the worker. You'd run those in EMR. You wouldn't run TensorFlow on the worker. You'd run something in SageMaker, right? Use the dedicated. The point of Airflow is to be running operators that make sense out of this stuff, and then go through and orchestrate and see how that other thing did. You don't run your ETL or ELT directly on the thing that does it, like Snowflake or Redshift. Don't try and rewrite all this stuff in Python. Just because you can doesn't mean you should. And so what Airflow can do very much for you is understand sort of how to prioritize and pool these things. If you have a downstream database that has a restricted number of connections, you can use pooling to say, well, I'm only going to have so many of these types of database connections open. You can weight certain things to make sure these DAGs are more important than those DAGs, these tasks are more important than those tasks. And you can also limit sort of the parallelism and say, okay, how many things are going to run at any given time? How many of these DAG runs can I run multiple copies of the same DAG, or do I have to wait for the previous one to complete successfully before I do so? So when we're talking about also scaling DAGs, it's also about, well, how I may have many different things I want to describe, but I may not want to write a lot of code to do it. And this is one thing that Airflow does really well, but it also presents its own challenges. So one thing that often folks get confused with Airflow is that the file that's in the DAG folder is not in and of itself a DAG. The Python file describes DAG objects, and these are just Python objects. And so what Airflow will do is it'll go through and load this Python file, return what's called a DAG bag of all these DAG objects, and that determines exactly what workflows are run. You can create what's called a DAG factory by saying, well, I'm going to use, say, a YAML file or a JSON file to describe the way I want these things to be done. And then I'll have a Python code that reads that file and still creates the objects. But either way, the ultimate thing is that it's not a one-to-one relationship. This Python file equals this workflow. It's a one-to-many, or in some cases, you'll have a utility file that's a zero, one-to-none. So important distinction to make. So one of the benefits of this, though, is that you can do some pretty cool things with dynamic DAGs. And this is on the left-hand side, I've got the idea of saying, I've got 3 tables, and I'm going to go through and write expressly, I'm going to run a Postgres operator for each table. Well, instead of doing that, I can actually go through and request from the Postgres database the list of tables, and I'm just going to run a Postgres operator for each table. That way, if somebody adds a table or removes a table, the DAG will be updated automatically. Now, you do have to be careful with this because let's say somebody adds 1,000 tables. Now, all of a sudden, it's going to try and create 1,000 DAG objects or 1,000 workflows. So you do want to make sure you're careful with that, put some controls in. Otherwise, again, you run into that issue where you've got a fixed amount of compute and you'll run out of it. So you can also do some cool stuff where you make it a little more efficient. So instead of reading from the database itself, I have one workflow that's job is to go to the database, get the list of tables. And then a second workflow that reads the results of that first workflow, and then that's when it decides to actually create the DAGs. And so you can do some things to make your dynamic DAGs significantly more efficient. And so that way you can go through and say, okay, well, I'm going to take this information and read it from a table instead. And then I'm just going to go through and after that initial schedule interval, go ahead and do it. So another way to sort of scale your efficiency with regards to handling a lot of different workloads is employ some CICD pipelines, right? Have things that verify the control. You can use that same local runner you saw, automate that process of testing it. So before you try and upload a bunch of requirements that may not work, create an instance of local runner on a Docker or on an EC2 or ECS and try and test it that way first. Add it to part of your GitLab or your GitHub pipeline or that sort of thing as well. And then you can also sort of scale out your ability to handle DAGs, which is allow people to access their own specific DAGs within a single Airflow cluster. So the way you do this, Airflow has a concept of rule-based authentication or role-based authentication. However, one important consideration is that Airflow is not truly multi-tenant. If you can write a DAG, you can access the entire metadatabase. And so that means that there's no real hiding data from someone else. And if your Airflow environment can access something, anyone who can write a DAG can access those things. So whether you can see the person's DAG or not, that's sort of a UI restriction. Now, there is an Airflow improvement proposal, AIP1, that's going to address this. And the progress is already being made on that by the Airflow community, which is fantastic. But if you really require isolation between it, adding multiple environments or multiple Airflow clusters is really the only way to truly restrict who can see what and who can do what. So when we're looking at multiple environments, one thing is, well, how do we divide things up? So some simple things are, I might have a sandbox or a dev environment or pre-prod, prod, the stage of your development. As I mentioned, downstream access. What is it supposed to access? I'll put all the people that have access to Redshift go in cluster A, and all the people that have access to Snowflake go in cluster B. Thinking about how cross-environment, how clusters have to, does this DAG have to talk to that DAG before it knows whether or not it's able to run or not? Sort of like our DAG that reads the tables and then the DAG that creates the workflows based upon those tables. Of course, breaking up amongst teams, right? The marketing team has its own has its own environment, and then the finance team has a separate environment. And then also by sort of pattern and priority. If you have a bunch of workloads that run 24/7, 365 every minute, you may want to run those on one environment, and maybe you have another environment who only runs ETLs every night, and you maybe want to leverage auto scaling on that one so that it scales up at nighttime and then scales down to nothing during the day. When you're dealing with multiple environments, obviously being able to centrally manage and monitor is important. One benefit of MWA is that it's all baked in because with CloudFormation and CloudWatch, so you can go ahead and spin up environments. You can even do it as a vending sort of thing. You can build an environment to vend for your internal customers. But then you also have all of your metrics and things like that, your logs and everything you're essentially managed. So you can see when there's problems, if the scheduler heartbeat fails, you can alarm on it. You can see across all your environments if one of them is taking too long to parse or you're seeing one spiking up to a lot of running tasks. It lets you keep an eye on what's going on. You can leverage those tools that are built into CloudWatch to help there. So want to give an example of how you could potentially distribute DAGs across environments. So I'm going to take that same example. Let's say, though, you've got a bunch of CSV files that have to go into tables in Redshift database, for example. So I may want to have Airflow every time there's new files and read that list of files in S3, the CSV files, and know to load them into Redshift on a certain schedule, or maybe every time there's new ones. So it goes through and scans the list. Now that would be pretty potentially inefficient. What happens if all of a sudden somebody dumps 1,000 files in, or 2,000 files, or 10,000 files? We need to have a way of logically breaking these sort of things up. So, one of the things we could do potentially is every time a new file ends up in S3, we have a Lambda, which is just an AWS function that can serverless function that can trigger, and goes ahead and writes it to a database or a JSON file or something like that. And then Airflow can read that list and handle the transfers based upon that list. It doesn't help you that there's still a lot of files to do, but it could potentially organize things a little bit better. And again, you could have that either a JSON file being generated from that database list as well, the exact same way we did before. But what we can do to manage these across is I can take that same dynamic DAG workload, use a custom range of information, and say, okay, let's break this up across environments. We'll have the first environment do the first 400 objects, the second environment do the next 400, and so on, and spread that load out. But we can do that without having to manage multiple different workflows or even really manage multiple environments in any way, because we can have each environment set up exactly the same way. The only difference is a single configuration item. And then what we can do is we can take in our that same DAG we showed earlier and pull that configuration option, which tells me which sources I should be pulling from. And then that will let me sort of break it up across. So I can have each environment point to the same S3 bucket, point to the same DAGs, have a different configuration. And then when, this will handle the 1,200 S3 objects. And then tomorrow when there's up to 1,600, I spin up another environment, and now I have the capacity for the next 400. And, this is doing it fairly arbitrary by just some arbitrary number, but it also could be, by team. You could pull up which team's databases or which team's files they are, or by folder within S3, or you can structure it however you'd like. So real quick before we open up questions, and hopefully folks have added some questions in. But I wanted to touch briefly on what's next for MWA, and then hopefully we can answer questions if you have them. One is we get asked a lot about the Airflow REST API access. Airflow has a RESTful API that lets you trigger DAGs and retrieve information, things like that. So we are working on it. The service team, and we actually have an internal open source team within AWS that works on just open source Airflow. We're gonna work together to sort of get the API access to sort of the high bar of security and scalability we want. Right now everything's run through the Airflow web server, and there's some performance restrictions there. Now, we do expose the Airflow command line interface through a very similar mechanism, and actually under the hood, the Airflow code that runs is exactly the same, and you can basically do the same sort of options as the RESTful API. You have the same list of functions anyways through the CLI. The other thing we're working on is really getting new Airflow versions out quicker. Really want to make sure that we introduce processes that let us do the security reviews, do the deployments, get all the testing done, everything else quicker, so that you can get the newer versions quicker as well. And then last but definitely not least is really improving Airflow's performance on MWA, right? There's a lot of tweaks and improvements and things like that. We're constantly trying to improve. I mentioned the newer Watchtower versions for logging, but we're always adding and looking for ways we can get better performance. And that's really one of the real promises of a managed service is that without you having to worry about it, it's going to get better. And so we'll be able to give you a better performance and a better experience without you while you're focusing on just your business and trying to solve your internal customers' needs. So before we sort of open up for questions, there are some great resources out there. Obviously, our documentations page is a great place to look. In our landing page, you actually will take you to our resources page, which has a bunch of blog posts and stuff like that. We have a fantastic group of solution architects and specialists that have done a bunch of blog posts solving some specific needs around MWA and Airflow in general, and they're great resources. And then also there's the Airflow AWS Slack channel. You'll find myself and a lot of our open source team on there answering questions and helping out. So that's a great place to go and see what else is going on. And then so that's and I am on Twitter. I'll go through and post when we have new releases and things like that out there as well. But with that, I want to open it up to hopefully get a few questions. I see a few questions on here. First one is, what's the best way to run Great Expectations via MWA? Is it via plugin? Actually, Great Expectations is just a Python library. So I'm not an expert at it. However, I was able to actually just install the Great Expectations provider in MWA, and it seemed to work fine. So I expect that that should be the same experience. The great thing about Airflow is that it is all just in Python. So anything that you're doing that's also pure Python is generally going to work. You do run into some tricky bits when it comes to navigating all those different Python dependencies and versions, and that was why I showed a couple of examples earlier on that, because that's really important to sort of tweak, and especially when you start saying, well, I need Great Expectations, but I also need Snowflake, but I also need the latest Airflow Amazon providers that have the newer Redshift stuff, but I also have to pull things from BigQuery, but that's an older version of BigQuery. So this is really where you're like juggling these versions and stuff like that. So the local runner is really a great way to manage those requirements. It's a bit of a puzzle from time to time, and that's one of the downsides with sometimes with Python. But the upside is it's very transparent and easy to install. The only time you run into any potential restrictions with things that you can run on MWA is sometimes Python libraries are just shells for underlying runtime code. And so that's where things sometimes get a little tricky. We have some examples of that in our docs. There's an example, for example, with Oracle. Oracle's library doesn't actually do anything in Python. It's just a shell for all the Oracle libraries underneath. And so that takes a little bit of work to install, but there's usually a way around it, but it's not always straightforward.
Awesome. Well, thanks so much for answering that question. I've got a couple of questions, John. Really awesome presentation. It's just amazing to see how far MWAA is coming and the roadmap for the future. It just seems amazing. A question from me around sort of like the deployment model. It seems definitely that you're still using VPCs and the like, and perhaps that's to do with the fact that you're running sort of jobs on Fargate and things like that. Do you envisage a time where that whole VPC concept is just abstracted away from you? It's a bit like, say, for instance, like Snowflake, where you're just accessing it over HTTPS in the browser, and we don't need to be networking experts anymore.
So, it's a great question, and I'll pull up that diagram because it's not a bad one to talk to as well. When we released, well before we released Airflow, we talked to a lot of customers, which is, and sort of said, well, what's important to you? And, definitely customers wanted that easy experience, right? Where it stands up and the UI is there and everything's there. I don't have to mess around with a bunch of things. However, there was a very high percentage of customers that said, but I have on-prem databases. I have data that has to go through our corporate firewall because of data provisioning or data restriction requirements. I have I have to restrict my users to just accessing via the corporate VPN because that is our compliance and security regulations are on that. And we had such a large number of customers that had those restrictions. We landed on this, and this is one of the reasons why you see these sort of two VPCs that are stood up. One is that single tenant one, where each environment, even within the same account, has its own separate VPC with the database and it's got the UI. Having that separate service VPC allows us to give the ease of experience where, hey, I can just go to a URL and provide that my IAM principal allows it. It'll just pop up and there's Airflow. Fantastic. While also balancing that with, but I also need to access all of this corporate data that's only available inside the VPC. And so this was the balance between it. It would have been a lot easier to just stand everything up in a service side VPC. Poof, it just pops up, and it'd be that one click, no configuration. But the problem with that is then so many customers would just not be able to meet their use cases. This will meet far more use cases at the expense of, for the example you gave, it's slightly more complicated to set up, because if you literally only needed to access, let's say you were only accessing internet accessible data sources and you want to orchestrate that with Airflow, you wouldn't need all of this stuff. But that's the minority of the use cases. There's usually, at least with AWS customers, they have at least some, if not all, of their assets somewhere sitting on a VPC, because that's sort of the standard model for everything. If you're going to host something in AWS, it's going to be on a VPC somewhere. And so, this was the best compromise to meet the most customers' needs while trying to provide as easy an experience as possible.
Yeah, I guess, it's just that, those larger customers with their on-prem, direct connect, VPC, yada, 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 versus born in the cloud sort of customers that are just looking for absolute ease of use and, quick to sort of stand up and stuff like that. I work with, I've got a customer currently that's on-prem Oracle. So definitely I appreciate the need for this sort of stuff. But, I also work with a few customers that are, I guess, really sort of going for that sort of light touch, sort of as little management as possible. And so it's interesting to see sort of, the general direction of things. But yeah, there's so much documentation. I sort of, I've been standing up sort of a few MWA environments, and I'm just really pleasantly surprised at how quickly and easily it is. About 15 minutes to spin one up. So yeah, that's fantastic. Well, it was quite an early meetup for us, John. Usually we're at about midday Australian time. This one's at 9:30, so I think a few folks are prior to their morning coffees, so that's probably why we haven't had as many questions come through as we typically would. But I think a lot of folks will be tuning in after the fact and sort of catching up on this one. So really appreciate your time. If we've got any questions, I think you've put in a bunch of links. There's the Airflow Slack with the MWAA channel and the like. So that all sounds amazing. And a reminder to the rest of the audience that Data Bytes tickets and CFP are now available. So get involved. Thanks once again to John. Chat to you next time. Ciao.
Cheers. Thank you so much.